Okay, so in this video we're talking about Appendix E. Appendix E, and that is sums and sigma notation. So the idea is we're going to be working with some sums in Chapter 5, and it's going to be useful for us to use some shorthand notation. And so let's go ahead and define some notation. So suppose I have a formula for some terms. I'm going to call them A, and so I have A sub m plus A sub m plus 1 plus A sub m plus 2, and I sum all the way up to A sub n. We're going to see some examples of what we mean by that. But we're going to define some notation now, shorthand notation. So if you see a dot over an equal sign, that means this is a definition. We're going to use capital sigma, that's the Greek symbol sigma, and underneath I'm going to write my the first value of the sum. So I'm going to put an index in here as well. So I'm going to use I as my index. This is the index of summation, and this is the first number, first integer. Well, they could be negative, but normally they're positive. First number, and up here we're going to be putting the last number. And so in this case it's n, right? We're going from m to n. And then inside here, inside the sum, we're going to have a formula for how to compute the ith value of our sum. So in this case we would just have a sub I. Okay? And so this right here should be a formula for computing, right, the ith value of the terms. Okay, so let's try a few. Suppose I've got the sum for I equals 1 to 4 of 2 times I. Can we expand that out? Well, notice that if I equals 1, I'll just kind of make a note down here, then this term is going to be 2 times 1, which is 2. And then for I equals 2, by the way, you're always assuming that the index is increasing by 1 unit each time. So we start with 1, and then we go to 2. And so this is going to be 2 times 2, plus, and then I equals 3. So that would be 2 times 3, plus, and then I equals 4. 2 times 4. Okay, these are just here to clarify what the sum looks like. You wouldn't actually write those down usually. Okay, and so this is the sum that's represented by this notation. Good. Let's see if we can go in the other direction. Suppose I've got 1/2 plus 1/2 squared plus 1/2 cubed plus 1/2 to the 4th plus 1/2 to the 5th. Can we write that using sigma notation? Go ahead and pause for a second. Okay, are you back? So we'll go ahead and use I as our index again. So we'll say that I is equal to 1. We're going to start here with a 1 power, 2 power, 3 power, 4 power, 5 power. So that's going to be y equals 1 to 5. And then the generic term inside here will be 1/2 to the I power. Good. All right, did you get that? We'll see. Let's try working back and forth again. How about if you have the sum, oops, I equal, we'll keep I for now. How about I equals 3 to 6 I squared. Can you pause and tell me and expand that sum? So I equals 3 to 6 I squared. Okay, well, we have I equals 3, and then we'll sum our term for I equals 4. We'll just go ahead and just make a note of this here. I equals 5, then I equals 6, right? So I equals 3 will be 3 squared plus 4 squared plus 5 squared plus 6 squared. Good. So then we could get rid of our scratch work here on the side. Good. And then sooner or later, or sooner, pretty soon, you'll be used to these and you won't need the scratch work there. Okay, how about a few more? We'll go in reverse again. How about if I have 1 plus 1/2 plus 1/3 plus 1/4? Go ahead and rewrite that in summation notation now. Are you back? So we can take I equals, there's several ways to do this. I'll go ahead and take I equals 1, 2, 4, and then the ith term, so this is 1, 2, 3, 4, right? The A equals 1, or I equals 1, I equals 2, I equals 3, I equals 4. So it looks like 1 over I, right? And that would do it. Good. How about another one? How about the sum k equals 5, oops, 5 to 8, minus 1 to the k times x to the k. So notice that in particular the index of summation doesn't have to be I could have written that as k, right? So in this case we're going to take our k equals 1, k equals 2, oh, k equals 5 first, k equals 6, k equals 7, k equals 8, and compute the terms for that. So that'd be minus 1 to the 5th power, which is minus 1, and then x to the 5th, so that'd be minus x to the 5th. Then for k equals 6, the minus 1 to the 6th would be a positive number, and then we would have x to the 6th power. And then for k equals 7, we'll have a negative number again, plus times x to the 7th, plus x to the 8th. Good. And so that would be our sum. And so one thing I would have you notice here is that when you have a minus 1 to the k power, what's happening is that the terms of the sum are alternating plus minus plus minus plus minus, or minus plus minus plus minus plus. Okay, so that's what the effect of having this minus 1 to the k power will do. Good. How about the square root of 3 plus the square root of 4 plus the square root of 5 plus the square root of 6? How would you write that? Ugh, my sigma's getting bad there. Write that in sigma form. Okay, are you back? What index did you choose? Did you choose I or k? I'm going to choose j just for fun. And so I'll have j is equal to 3 to 6, and then this would be the square root of j. Good. True or false? I could have written the sum as the sum, let's say j equals 0 to 3. Let me write n equals 0 to 3 of the square root of n plus 3. Would I get the same thing? I think I would, right? So when n is equal to 0, I have the square root of 3. When n equals 1, I have the square root of 4. When n equals 2, I have the square root of 5. When n equals 3, I've got square root of 6. So that would work. And so notice that these are the same. They look very different because they're using a different index and a different formula, but once you've expanded the formula, they're identical. Very good. All right. And so one thing then is that the following are all the same. I could write, for example, the sum, if I'm looking at the sum from 1 to 6 of I squared, that would be the same thing as writing the sum j equals 1 to 6 of I squared. That would be j squared. That would be the same thing as n equals 1 to 6 of n squared. So notice the main thing is that we're being consistent here, right? These have to be the same. These are the same. These are the same. Okay. You could even write, like we were doing before, you could write the sum as like k equals 3 to 8 of k minus 2 squared, right? And you would get the exact same thing. Alright, so you can play some games with some algebra on the sum. In the next video, we're going to be taking a look at some properties of sums, and yeah, we might even prove some things. So see you then.